Say I don't feel like doing anything. I just wanna learn sequences. Don't feel like writing a Shakespeare. My calculator is right here. 'Cause today I'm gonna learn sequences.
Well, hello once again, Algebra 1 students. So here we are looking at geometric sequences in lesson 6.6 in our Big Ideas curriculum. And we've already looked at arithmetic sequences, so sequences should not necessarily be a new concept to us, but there are two types of sequences that we do discuss, and it's arithmetic and geometric. Arithmetic sequences are going to be more along the lines of a linear function. So that's why we looked at those earlier when we were doing linear functions. And now geometric sequences are more along the lines of exponential functions. And so that's why we looked at them here in chapter 6. So we are going to be identifying geometric sequences from a list of numbers. We'll be extending and graphing geometric sequences as well as writing sequences as functions. So before we do that, let's go ahead and look at our cartoon. And this one you might want to just pause the video to kind of really get a good look at this one to see all the different snowmen that Calvin has made over, the different times of the year. Several different cartoons are kind of compilated right into this one here. All these different snowmen that he's made. He's famous for making interesting snowman creations. All right, let's go on to looking at our core concept. Page 195 there in your notes, we see the core concept on geometric sequences. Now, as far as the vocabulary, it is right here in your notes. It's highlighted. You can highlight those as well in this core concept. The geometric sequence, it says that the ratio between each pair of consecutive terms is the same. Okay, so we're talking about a common ratio then. And that's what this next part says. It says that ratio is called a common ratio. Each term is found by multiplying the previous term by the common ratio. And what I wrote down here is what you might want to write kind of more in less technical terms. Basically, a common ratio is a common number that you multiply by to generate the next number in the sequence. So here's a sequence of numbers 1, 5, 25, and 125. And you can see we're multiplying 1 by 5 to get 5, and then 5 times 5 is 25, 25 times 5 is 125. So the common ratio is the number 5. You're going to multiply by a common number, that's the 5, to generate the next term in the sequence. So to generate the next term after the 125, we would multiply 125 by that common ratio number 5. And that's just basically how that would go. Now sometimes, as you can see here, 5 is more than 1, so it's going to be causing this to increase and get bigger and higher. The number will get even bigger as we keep multiplying by 5. But if this number is between 0 and 1, like a decaying function, we've seen that in the past with exponential growth and exponential decay, so this would be considered like exponential growth. We're multiplying by 5 every time. If this was like 1/5, then we would see that this would be getting smaller every time, and that would be more along the lines of exponential decay. All right, let's move on to looking at our extra practice there on 196. So if you turn your page in your book at the top of 196, you'll see these 6 problems. It says to determine whether the sequence is arithmetic, geometric, or neither. And so I'll go ahead and take a look at 3 of these, and you can take a look at also 3 of them yourself. So I'll move this down a little bit. So we have number 1. Is this arithmetic? Is it geometric, or is it neither? So we need to remember, okay, what was arithmetic? Arithmetic is where we had a common difference number. So that's where we had a common difference, and if you were adding or subtracting the same number every time, that would be arithmetic. Geometric is where we are multiplying by the same number every time, or it could also be even dividing by the same number every time. You can kind of think of it in that way, but I really would suggest think of it more in the terms of multiplying, because that is where we're going to really be focusing later as we're writing these things. If it's doing neither one of these, then you would just choose neither. All right, so number 1, what are we doing here every time one to negative 4, then something times that did 16. So you can see what we're doing there. Every time here we are multiplying by negative 4. You're multiplying 1 by negative 4 to get negative 4. The negative 4 times negative 4 to get positive 16, and so on. So you're multiplying by the same number every time. A common ratio is the negative 4 here. So you have a common ratio, so that means this is a geometric function. Let's take a look at number 2. On 3 to 7 to 11 to 15, what's happening here every time? Is there something happening that's the same? Well, in this one, you could see we are adding 4 every time. 3 plus 4 is 7. 7 plus 4, 11. 11 plus 4, 15. You're adding 4, which is a common difference. So since on this one we have a common difference, that would be an arithmetic function because we're adding the same number every time. So when you multiply by the same number, it's geometric, but when we add by the same number, arithmetic. And then for number 3, 2 to 4, 4 to 8, 8 to 32, on this one, as we can see, we would like multiply maybe by 2 times 2 is 4, 4 times 2 is 8, so it seems like it might be geometric there, but when we do 8, 8 times 2 is not 32, it's actually 8 times 4 is 32, so it did not have a common ratio. It does not even have a common difference here between these numbers. Like this would be adding 2, this would be adding 4, this would be adding a whole lot more. So this one would be neither. It's neither arithmetic or geometric, and the reason why here is because there is no common difference and there is no common ratio. That's why it's neither. Alright, so go ahead and pause the video, and then once you try 4, 5, and 6 and see if you can do the same thing on these 3 as I was doing on the top 3. So pause the video and then check your answers once you're done. Alright, so hopefully you've got an answer there for 4, 5, 6. You've looked at these here and seen if they're going to be geometric, arithmetic, or neither. On this one, we had 12 to 9, 9 to 7, 7 to 5. So it looks like we are subtracting 3 from 12 to 9. But then when we go from 9 to 7, you're not subtracting 3, you're subtracting 2. So, and you're subtracting 2 there. So there's no common difference, there's no common ratio either. So this would be another neither. There is no common difference or a common ratio on that one. That's why it's neither. Number 5, 6 to 18, 18 to 54, and so on. This one you can see you are multiplying by the same number. You're multiplying by 3 every time. 6 times 3 is 18, 18 times 3 is 54, and so on. So our common ratio number is 3, and this means it's a geometric when you're multiplying by a common number and you have a common ratio. Number 6, you have 11 to 19, 19 to 27, 27 to 35. This one we do have something in common. We are adding 8 every time in this one. So each of these going along, you're just going to add 8 to get the next number in the sequence, which means you have a common difference. So that would be arithmetic. It's an arithmetic one when there's a common difference. Okay, let's go ahead and look at our next few problems there. 7 through 9, they're in the middle of the page on 196. It says write the next 3 terms in the geometric sequence. Okay, so first of all, it tells us right here in the instructions that it is a geometric sequence. So we know we're going to be multiplying. We know we're going to have a common ratio number. We just need to figure out what that common ratio number is. So for number 7 here, it starts with 7, then 21. So you can kind of think, okay, well, what are you multiplying 7 by to get 21? You'd be multiplying by 3. So you could try that. You could say we're going to 7 times 3 is 21. So since you're timesing by 3, that's your common ratio number. R we'll use as a common ratio. The ratio is 3. So if we just keep multiplying by 3, so now we have 189. The next number we need to multiply 189 times 3 to generate the next one. 189 times 3 is 567. And then then we got to multiply 567 times 3 to get the next one, and that's 1701. And then we got to multiply 1701 times 3 to get the last one that we need, 5103. So that's the next 3 numbers in this geometric sequence. Number 8, this one you could see we're kind of coming down. We're getting smaller every time. So to find the common ratio on this one, it might be better, because you're trying to figure out what are you multiplying by every time. Well, it's a smaller number than 1. It's less than 1. It might be better then to do it this way, to go from maybe this smaller number 72 up to the 144, and you could say you could do a little division, do a fraction. the 72 over 144 and then simplify that fraction, and it would simplify to a 1/2. So your R, your common ratio, is 1/2 or 0.5 in this problem. So basically we're saying half 144 times a half is 72. So the next number would be taking 72 and timesing it by a half. And so 72 times by a half is 36, or you can think of half of 72 as 36. And then we do half of 36 to get the next one. Half of 36 is 18. And then half of 18 would give us the last one we'd need, which would be 9. So 36, 18, then 9 are the next three numbers in the sequence. All right, so go ahead and pause your video and then just try number 9. See if you can do the same thing with number 9 and then play it to check your answer. All right, so hopefully you've got number 9 done and you have the next three numbers in that sequence. Let's just check to see if you first got the right common ratio. That's the first thing you needed to get, which in this case is -2. You could see from 5 to 10 we are getting bigger, but we are changing the sign every time. So we're multiplying by negative. 5 times -2 would give us -10, and that's what we're doing every time. And we're multiplying by -2. So we need to multiply -40 by -2, which gives us 80 for the fifth term. So that's our fifth one in the sequence. The sixth one would be -160 when we multiply 80 times -2. And then the last one we'd need would be 320, positive 320. That's multiplying -160 times -2. All right, so if you got those numbers and you understand just how easy this is to generate the next three numbers in this geometric sequence, first identify what that common ratio is, and then you just got to multiply by that common ratio. Okay, so our next three problems here, we have to actually put these on a graph now. It says write the next three terms. We're going to do the same thing as we did before, writing the next three terms of the geometric sequence. But then we need to graph the sequence. So after that we need to graph the sequence. So let's take a look at first finding the next three numbers in the sequence. So we need to identify what the common ratio is of each of these. So once you pause your video at this time and just do that first. What is the common ratio of the geometric sequence of each one of these from 10, 11, and 12? And maybe at that same time what you want to do is also draw this, the kind of like the L graph here. This is all just the first quadrant of a coordinate plane, and number these just like I numbered them here. So you want to have it numbered and drawn the same way, so we're ready to graph them when we're going to get to that part. So identify what the common ratio is for each one of these, and then also draw these graphs the way I put them on here. Okay, so hopefully you have a common ratio now for each one of these, so we can see we're going down on this one. So for this one, you could see that what are you doing each time? You're cutting this half. Half of 12 is 6, so our common ratio here, the R, is going to be 1/2. So we're going to see it is 1/2 each time. We need to multiply this number by a half. So 3 over 2 times a half, so the next number in our sequence here would be multiplying this. 3 times 1 on the top is still 3, but then it's going to be 2 times 2 is 4. So it's 3/4 for the next one. And then 1/2 times 3/4. 1 times 3 is still 3, but then 2 times 4 is 8, 3/8. And then for the last one, 1 times 3 is still 3 on top, and then 2 times 8 is 16. So now we just need the last thing to do then. There's our writing the next three numbers of the sequence, and we need to now graph these. So starting with 12, now this is our first one, our first term. So I'm going to number each term. First one is 12, second one is 6, third one is 3. This is our fourth one, which is like 1.5, 1.5. Here's the fifth, the sixth, and the seventh. So as we graph these on this graph, the x-axis are these. So here's your x, these are your x's, these are your y's. So your x's are just the position number, first position, second position, and so on. And then the y is the actual number in the sequence. So first position, we're at 12. So we go all the way up to 12. We'll put a dot right there. There's first position. And then second position, we're at 6. So 6 will be right here. Third position is at 3. So 3 is these are going by 2's, as you know. So 2, 4, 6, and so on. Each box is 2. So 3, I'm going to be halfway in the middle of this box. And at 4, I'm going to be at 3.5, so, or 3 over 2. So that's going to be 1.5. So 1 is halfway up, and then half of that is going to be like about right in here. 5, we're at 3/4. So 1 is halfway, 3/4 is a little bit less. 6, we're getting even smaller, so we're getting closer to like the x-axis here. 7, we're even closer. And so you can see definitely it has the shape of a decaying function, an exponential decay. All right, number 11, here's where we want to look for that common ratio. What are we multiplying 3 by to get a 12? Well, we'd be multiplying by 4, so common ratio here is 4. So fairly simple, and you can check that for the other ones. 12 times 4 is 48, and so on. So now just 192 times 4, so we can bring up our calculator for helping us on this. So 192 just times 4, that gives us 768. So 768. Okay, so now we need to multiply 768 times 4. Let's bring back our calculator. So now that's already on the calculator, 768. Just put times 4. 3,072. So 3,072. And then for our last one, I'm going to have to put it underneath here because I'm running out of space. Maybe I should have put this over here. Maybe I'll do that. So 768 I'll put here. There we go. 3,072. And for our last one, just need to multiply that 3,072 now by 4. So times it by 4. That's 12,288. So 12,288. All right, so again, we need to put these in positions. Our first position here, second, third position is our fourth, fifth, sixth, and seventh. So again, these are x's on top, our y's, the actual number in the sequence. So first position, we're at 3. So now notice how this is numbered here, since we're trying to get up to something really big. Every one of these is 1,000. So right here at the first position, if we're at 3, we're like so close here to the x-axis. It's like almost on the x-axis. At 2, we're not much higher. It's still like super close to the x-axis. 3, we're getting a little bit higher, but I wouldn't go too much more. 192, I mean, this is 1,000 here, so you're still just really close. These are still super close to the x-axis right here. Right along here, and then we start to take off a little bit. 768 is getting closer to 1,000, so we're going to put this on a little higher here. And at 6, we're at 3,000, so now it really took off. So here's 4,000, 3,000 is going to be just a little bit higher than this here. And then 7th position is at 12, so we're going to be actually off our graph. There's 10,000, 11, 12 is going to be something higher up in here. So you can see how that does match with what exponential growth was. It starts off real slow, but then all of a sudden it just takes off. Okay, for our next one here, this one might be a little harder to find that common ratio number, but you can see how it is. Maybe from here we're getting bigger. We are getting bigger. You can see 0.2 to 1. So what would we multiply 0.2 by to get 1? You could also do it this way. You could divide. You could say right here 1 divided by 0.2. It's another way you can find what you're multiplying by. 1 divided by 0.2, and we could do that on the calculator. So I come down here and just say 1 divided by 0.2 equals, and there it is, 5. Our R, our common ratio, what we're multiplying by on this one, is just the number 5. 5 times 0.2 is going to give us 1. So now to find the next number in the sequence, it's just 1 times 5, which is going to be 5. That's our next number in the sequence. And then 5 times 5 is 25. And then 25 times 5 again is 125. So there's our next three numbers in the sequence. If we number each one of these in position number, first position, second position, third, number 1 is fourth, 5 is 5, 6, and 7. Then we come down on the graph here, you can see on this one they're going by 20s. So each box is worth 20. So at the first position, we are going to be really small here, like really close to the, again, x-axis at 0.008. Still, again, really small. Again, it always starts off slow. 0.004, does not much higher. And then 1, so we are getting a little bit more. Again, this is just going up just barely. And then we come up to 5. So 5 is at 5. So 10 is actually halfway on this box. We're still not that much higher. At 6, now we start to take off a little bit at 25. So there's 25 more is here. At 7, here's where we really take off. 125 is going to be just a little bit higher than there. So that's what our graph should look like. Again, exponential growth is what it's modeling on that one. All right, let's come ahead and take a look at we have our joke of the day. If you need to pause the video and just finish writing something down, go ahead and do that. But let's take a look at our joke of the day now. So here we are with joke of the day. It says, two lawyers walking through the woods spotted a vicious-looking bear. The first lawyer immediately opened his briefcase, pulled out a pair of sneakers, and started putting them on. The second lawyer looked at him and said, "You're crazy. You'll never be able to outrun that bear." "I don't have to," the first lawyer replied. "I only have to outrun you." That's a good joke. You can outrun the second lawyer, then he's going to be okay, because the bear will get the second lawyer. Bear going to get the slower lawyer. All right, let's move on to our next core concept. So back on page 195. So here, now we're going to actually be looking at writing the model. So we're going to write a function model for these sequences. So far we've just kind of been looking at like 4 numbers in a row, a sequence of numbers. And we've been noticing that they're geometric. So now what we're going to do is we're going to take that sequence and we're going to put it into a function model like this right here. It says let a of n, that's where it starts here, be the nth term of the geometric sequence. So it could be like, if we want to find the 10th term in the sequence, that would be a of 10. So n would be the term of that sequence. With the first term being a of 1. So a of 1 is your very first term of the sequence. The common ratio would be r. So there's your common ratio number. And then the nth term is given by this. So n would be actually what number in the term, what position number are we going to be looking for? That's what the n would be. And so we can put it right here in the exponent spot. So it's n minus 1. So this is what we need to remember for writing a geometric sequence. We had this a very kind of similar one when we wrote an arithmetic sequence back some time ago. Okay, so here's a little thing that just might help you identify this. If we said, okay, a of 1 was just the number 1 and our common ratio was 5, so you can kind of see how we would use this model here. If your a of 1 was 1 and your common ratio was 5, first position, so this would be our n number. N is 1, n is 2, 3, or 4. You can kind of see how we were going to get these numbers. We start generating this sequence by doing this. So if we put in 1 inside of here, 1 minus 1 is 0, and so we would get the common ratio to the 0 power. That's going to be 1. 1 times 1 would just be 1. For this one, it would be 1 or 2, second position, 2 minus 1. 2 minus 1 is 5 to the first power. You'd see that right there now, which is just 5, and so 1 times 5 is 5. If you put 3 here for the third position, 3 minus 1 is 2, and so we're going to get 5 squared. 5 squared is being 25. 25 times 1 is 25. And then same thing here, fourth position, put 4 here. That's going to give you a 3 for an exponent. 5 to the third power is 125 times 1 is still 125. So that's what we're kind of doing every time. We're just putting in the position number for the n. That is the n number. Okay, so now as we take a look here at some of these, 13 to 16 give you the sequence in just a list. 16 and 17 give you that sequence in more of a table of values, more of a kind of a table chart. And then the last few problems give it to you on a graph form. So basically we're doing the same thing for all of these from 13 to 20 though. We are going to write an equation in this form right here, that geometric sequence, and then it says to find a of 6. That would be the sixth term. So far they just give us the first 4. We need to find the sixth term of that sequence. We'll do that trying to use this model after we get the model. So the first thing to do is to actually just write this down in a function model using this function here. So first term right there is 65, 61 on number 13. That is our first term. We got to find also the common ratio. So two things we need to know. What is the first term of the sequence and what is the common ratio to be able to just write this in here. So that's what we're doing. First term, a of 1 is 65, 61. Our common ratio, it is going down, so it might be best to go from the smallest number you see here, 243, put that over 729 in fraction form, and then reduce that. So 243 does go into 729 3 times. So it goes into itself once, into that 3 times. That's a 1/3 common ratio. So as we plug it in now, so a of n, we start with that. It's kind of like the y. A of n is very much like y in function, or just your function f of x or y. So it's just more like the sequence notation for y. Equals your first term, 65, 61, times the common ratio to the exponent of n minus 1. Right now we're just going to put the n minus 1 here because we don't have to put an n until we have to find the sixth term on the next part here, which we're going to do under here. So if we put 6 inside of here for n, 6 minus 1 is just going to be 5. And so now what we need to do is 1/3 to the 5th power and then times it by 65, 61. So here's where we want to use our calculator. So we'll say 1/3. Now with the 1/3 I need to put this in a parenthesis. I'll show you why, because if I don't put it in parentheses, I'll first put it in parentheses and show you 1 divided by 3, close parenthesis, so that gives me that as a decimal. Then I can raise it to the power I want, so x to the y power, 5th power, equals, and there's that number we need, and then we multiply it by our first term, 65, 61 times 65, 61 equals the 27. That's the sixth term. So the sixth term is 27. That does make sense. It should be definitely getting lower than 243. If I did not put parentheses here, and I just did 1 divided by 3, and then raised it up like this, I don't think that's going to give it to me correctly. Let's try it. But let's see. 5th power. And actually it did. It did recognize it. Some calculators don't. So you got to be careful there. So this calculator looks like it did recognize that. Times 65, 61, 27. So yes. So I actually didn't need the parentheses on this calculator, but some calculators I do. So you just got to be careful doing that. Alright, so now you've seen what I've done here. Let's go ahead and try another one, and then I'll have you try the last one there. So this next one, 14, first term you can see definitely is 8. It's right there in front of you. And then what's the common ratio? What are we multiplying 8 by to get a negative 24? We're multiplying by a negative number, and we're multiplying by 3. So negative 3 is what we're multiplying. You could also do it this way. You could put negative 24 over 8, and you can see negative 24 divided by 8 is a negative 3. Either way, you want to see your common ratio is negative 3. So a of n equals 8, your first term, and then in parentheses, negative 3, and then just n minus 1. That's the first part of what they ask us here, to write an equation for the nth term of the geometric sequence. So that's our answer to the first part. The second part, finding the sixth term, we would put 6 here. So 6 minus 1 is 5 again, just like we're going to do here. So I'm just going to put 5 there. And so it's going to be negative 3 to the 5th power times 8. So if I do my calculator and I hit 3, and what I could do is I could raise it to, I know this is going to be negative number here, because 5 negatives is going to stay negative. So that's why I know I'm definitely going to get a negative answer here. So if you know that, you don't have to really put in the negative. If you know your answer is negative, if you want to try to put the negative in, you could try to do that and then say we're going to raise this up to the fifth power. So it gives you negative 243 and then times by 8. There's the negative 1944. So that's the sixth term, not the next term, but that's the sixth term of the sequence. And we can find any term we want to. So if we wanted to find the 10th one, we put 10 minus 1, and our exponent would be 9, and we could do the same thing on the calculator. Let's go right now, pause the video, do number 15, and then play it to check your answer for 15. Alright, so hopefully you've got number 15 finished. Obviously you know your first term's 3, your common ratio, you're multiplying by 5 every time. So your common ratio is 5. So you should have written down this, a of n is equal to 3, that's your first term, and then parentheses, 5 is the common ratio, n minus 1 is the exponent. That's the first part. The sixth term would just be saying 6 is n, so that's going to be 5 to the fifth power, then times 3. So if I do that on the calculator, 5 to the fifth power is that number, then times 3 is equal to 9375. And so our answer should have been 9375 for the sixth term. A of 6 is 9375. Okay, number 16 and 17 are pretty much the same idea, same kind of thing. This one is going down, this one's going up. I'll do the going one up here. Let's take a look at this one. So our first term right there, you can see position 1, first term is 11. Common ratio, what are we multiplying 11 by to get 44? That's just 4. So our common ratio is 4. You could also do 44 divided by 11 to get that. So that would tell you what you're multiplying by. So you write your answer of the first part as a of n equal to 11 and then 4 to the n minus 1 power. And then for our sixth term, still going to get the sixth term. So again, it's going to be 5 for exponent, 4 to the fifth power. Actually, I'll move this on the side. So if I bring up my calculator, 4, raise it to the fifth power, equals 1024, which we got to multiply it by 11 now, the first term, times 11. And it equals 11,264. So that's what we have here. So our sixth term would be 11,264. You can see how this is definitely a growth function. This would just be exponential growth. So go ahead and pause the video at this point and do number 16. You can see this one's going down. It's a decaying function. So go ahead and pause the video, do 16, and then play it. All right, so hopefully you have an answer for number 16. The way your function should be written out, a of n first. Remember, you're going to always start with a of n. First term is this 2916. Your common ratio, well, you need to, I would probably do 108 over 324 as a fraction. So 108 over 324. 108 does go into 324 exactly 3 times. So it goes into itself once and into 324 3 times. It makes 1/3 our common ratio. So you need to realize when it's going down, your common ratio is less than 1. It's got to be a fraction less than 1. So there's what it should say now. Your first term, 2916, common ratio 1/3, n minus 1. And then if we do the 1/3 to the fifth power, because we're going to put in 6 again, finding the sixth term. So fifth power, what should that be? So again, we could do the same kind of thing we did on number 13. So 1 divided by 3 on my calculator here, since I don't need the parentheses. And then I can just raise it up to fifth power again. So fifth gives me that same number I got before, and I just need to multiply it by the 2916. And that would give me a number of 12. So you can see how this one's getting smaller. It needs to continue to get smaller from 108. So if it got bigger, if your number was bigger than 108, you went the wrong way. So definitely need to keep getting smaller. These numbers keep getting smaller. Alright, just a few more problems. Now we're going to look at the graphs. And it's basically the same thing as we just did before. It's just now the sequence is now plotted for us on the graph. And the ordered pairs are here. Here's 1, 2, 2, 6, 3, 18, 4, 54. So you can see how this one, it's definitely going up. So your first term, your second term, third term, fourth term. So I'm just going to put our first 2 terms down here. So first 2 terms, we can see on first term, there's our a of 1. So the first position, it's 2. A of 1 is 2 in this one. So as we write it out, the first number is going to be 2. Common ratio, second term is 6, so you want to use 6 and 2. 6 over 2, or 6 divided by 2, is 3. So you got to go backwards to be able to do that. From second one to first one, you can put the second one over the first one and then get your common ratio that way. That way you could see, yes, you're multiplying 2 times 3 to get 6, 6 times 3 to get the 18, 18 times 3 to get the 54. That's how it's growing. You keep multiplying by 3 every time. So that's what our equation should look like. And then again, finding the sixth term, we're going to put 6 in here. It's going to be 5. So 3 to the 5th power, then times 2. So on the calculator, 3 to the 5th power is 243, then times 2 is the number 486. So there it is. Our sixth term, A of 6, is 486. All right, so I'm going to have you pause the video, try this next one, try 19. We'll do 20 together there at the end, but try 19, see if you can do that one all right. All right, so if you finish 19, now you're just checking your answer. So your first term right there is the first ordered pair where it says 1, 3. So this one's got 3 for the first term. And then the second term is 6. So you could do 6 divided by 3 to find the common ratio. Or what are we multiplying 3 by to get 6? That is definitely 2. And it is growing, so it should be more than 1. So as you can see, it's exponential growth going up. So 3 is our first term going here. 2 is the common ratio going in the parenthesis with n minus 1 as the exponent. That's the first part. And then again, we're going to put in 6 for n to find the sixth term. So 2 to the 5th power times 3 is really, 2 to the 5th power is 32. 32 times 3 is 96. So 96 should be your number for the sixth term on that one. And it should make sense. It should be more than 48. It's going to keep going up. And then this last one here, for number 20, this one, it seems kind of odd because it's kind of going all over the place. It's bouncing around. Goes from first term being 8, second term is -4, third term goes to 2, and then back to -1, then to 0.5. So this one, it's kind of going back and forth between above the x-axis, below. So it's giving me multiplying by a negative on this one. So our first term is still going to be 8. But then when you want to look at, see, okay, what are you multiplying 8 by, maybe to get to a -4? Or you could do -4, and I think this might be easier on this one, since the numbers are going down, 8 to -4 to 2 to -1, is to do -4 over 8. -4 divided by 8. And so definitely it's a negative common ratio, and then 4/8 is the same as a 1/2, so -1/2. So here's what our equation should look like. First term 8, common ratio -1/2, n minus 1 is your exponent. And again, we're going to put in 6 here, and so we have to use our calculator probably on this one. We could do 1/2, 1 divided by 2, and we could even make that a negative. See, that didn't work out there. Put the negative behind it. So sometimes you got to be careful there. You could also do 0.5. You got to do 0.5 and then negative. There it is. So you could do it that way, and then I could raise it up to the 5th power. To the 5th power, and it equals that number, and then times it by 8. So times 8, and it equals -0.25. That would be my number. So that's our number for this one, -0.25, or I wrote it as a fraction. 0.25 is a 1/4, so it's the same thing, -1/4 or a -0.25, as you see on the calculator here. So that's our answer for the sixth term. All right, so that is it for 6.6 on geometric sequences. So that's actually going to conclude. I'm not going to be doing 6.7. So the next lesson you'll see will be our first lesson in chapter 7. So until then, until we get to chapter 7, I'll see you then. Have a great rest of your day. You guys take care.